Hello students, good afternoon all of you. So welcome to Avanti chemistry classes. So we will wait for other students. We will wait for 2 more minutes. Then we will start the class. Okay. I think you two friends are waiting for us there. So good afternoon all of you. So very good afternoon. So how is your JNV life going on? Anyone in the chat box? Anyone? Is it going good? Or exams? Or sports? So what is going on there? Okay, well and good. So, so we have completed chemical bonding chapter. Our Gopi sir has completed chemical bonding chapter. Then the most important chapter in your class 11. What is that? Organic chemistry, some basic principles and techniques. So a very long name, right? So we chemistry people, we are very lazy. Are we lazy? No, we are not lazy at all. So we have to study about this organic chemistry today. Okay. So we have studied so many chapters, but it's very important to study this organic chemistry chapter. So first of all, before starting, I'm launching the technical report. Okay, if everything is fine, let me know. If there are some technical issues, we will resolve that and we will move forward. So I have launched the technical check. If my audio is perfect, if my screen is properly visible, then you can give some thumbs up. Anyone, you two friends, you can answer me in the chat box, live chat. There you can answer me. Is it perfect or is there any technical issues? I hope everything is fine. I have launched a technical check for you. So you have to answer that. Then only we will start the class. So I hope, okay, good. So I'm ending this poll. Just a second. Okay, good. YouTube, everything is fine. Okay, if everything is fine, let us start the chapter. So we are going to study about organic chemistry. So you have studied this physical chemistry, right? So physical chemistry you have studied. Then what? Then this inorganic chemistry you have studied. Then last we are going to start this organic chemistry. Last, not the least. Okay. So if you understand the organic chemistry properly, then it's very simple to score full marks from this topic. But most common thing that we see is in 12th, you will say, sir, we don't know anything about organic chemistry. It is very difficult to study this organic chemistry. So this is the right time. So this is the right time to start the learning. Okay. So physical chemistry, okay. Inorganic, okay. Then now we are going to start the organic chemistry chapter. So who is the king in our organic chemistry? Who is that? So carbon is the king in our organic chemistry. So there are so many carbon atoms present. So one carbon, the next one is coming. So again, one more, then one more. So this carbon, this carbon is combining together. They have a self-linking property. So can anyone tell me what is the self-linking property of carbon known as? We have studied this in your 10th. So I will tell you the chapter name, the carbon and its compounds. So carbon, carbon, carbon. So there are so many bonds formed by this carbon. So this self-linking property of carbon that is known as catenation. So what is this catenation? So the carbon is combining. Okay. So I think you might have seen the Bahubali movie. There is a scene This Prabhas and this OGS, they are carbon atoms. They are linking with each other. Then they are going to the pot. Okay. Similarly, this carbon is making bonds with other carbon atom and a large molecule is formed. So catenation, that is a self-linking property of our carbon, and a large chain is formed. So because of this property, so variety of organic compounds are present. So because of this property of carbon, we are studying all these things, right? So this is our organic chemistry, like Bahubali. So this carbon is also linking with others or self-linking. Okay. So introduction to organic chemistry. So we will study about this nomenclature. Nomenclature, IUPAC nomenclature. So that is our first topic. Then after that, we will study about GOC, General Organic Chemistry. Sir, what is General Organic Chemistry? Nothing. We will study about basic things in organic chemistry. Then after that, we will study about some isomerism. Isomerism, can anyone tell what is this isomerism? So you have studied this isomerism already, right? Then in GOC, there are so many electron displacement effect. So you might have heard about that, but we will study about this electron displacement effects in detail. There is inductive effect, resonance effect. Resonance you have studied in chemical bonding also somewhat. We will study that resonance in detail. Then there is hyperconjugation. There is electromeric effect. So we will study all these things. So starting IUPAC nomenclature, then GOC and isomerism we will study. Then there is a chapter called hydrocarbons. So there are so many reactions and everything. We will study this hydrocarbon. So first we have to make the base clear. Then only we can study this hydrocarbon chapter. Then in your 12th, there are so many organic chapters. Second textbook that is full of organic chemistry. So if your basics are clear, then simply you can score full marks in your board exam as well as these competitive exams. Okay, so without wasting any time, let us start our organic chemistry chapter. So we will study about first representation, how to represent the molecules. Then nomenclature, that is naming. So newborn baby, so like a baby, we have to name our organic compounds. So that is known as nomenclature, that is naming of alkanes. We will study about alkenes, alkynes, different group. Then nomenclature of compounds with functional group. If the base is clear, then next level. Okay, then there is nomenclature of aromatic compounds. So from this aromatic compounds, in NEET 2022, a question was asked. We will discuss what is this aromaticity. So what are the aromatic compounds? So all these things we will discuss. So step by step only, we will move forward. Okay, I hope it is clear to you. Then, so organic compounds. So what is the importance of organic chemistry in our life? So you may ask, sir, why are we studying this organic chemistry? So we have to study a lot of things. Actually, this organic chemistry is highly useful in our daily life. Do you know any example for that organic compounds which is very helpful in our daily life? Anyone in the chat box? Do you know that? Or I will tell you. So you have studied this chapter, biomolecules, biology, not chemistry. Okay. So actually these subjects, biology, chemistry, all of them are interrelated. So don't see it as a different subject. So DNA, you have studied DNA, deoxyribonucleic acid. In that, there are some base pairs present. So can you tell me any base pairs? I think there is adenine, then thymine, then cytosine, guanine. So these are base pairs and they are very important in our DNA. Then this adenine and thymine, they are forming some bond. So can you tell me whether it is single bond, double bond, or triple bond? I don't know. I'm not a biologist. You are biology people, right? You are NEET aspirants. So you have to score full marks in biology. Then cytosine and guanine. It is also forming some bond, right? So is it a double bond or triple bond? I don't know. So you have to check your biomolecules chapter. So this is a homework for you. So adenine and thymine. So what is a bond form? Double, single, triple. So you have to tell me in the next class. If you know the answer, you can give the answer in the live chat box or here in the Zoom meeting, right? So DNA. So DNA, organic compounds are present. So DNA, without DNA, we can't live. So our organic compounds are very important to us. So is it useful in our daily life? So that is why we are studying this organic chemistry. There is a reason behind everything. Okay, then some more fuels, petrol, diesel, they are all hydrocarbons. So here we have octane. We will study about octane number. Okay, so fuels, they are mainly hydrocarbons, that is carbon and hydrogen is present. It is also an organic compound. So fuels, without fuels, we can't do anything, right? So daily life, so morning bus journey or car journey, etc. Okay, so I got the answer in the live chat. Okay, double bond and triple bond. Yeah, right. ATGC. That is correct. This base pairs are forming bond, double bond and triple bond. That's great. So fuels, that is another importance of our organic compounds in our daily life. Petrol, diesel also. Okay, we usually say petrol pump. Diesel is also there. Still, we are saying petrol pump. Why? Is there any reason for that? I don't know. So then polymers, PVC pipes. So PVC pipes we are using in our home, then school also. So polyvinyl chloride. So about this polymer, there is a separate chapter in your 12th class. So again, polymers you have to study. This is structure for PVC. So N number, what is N? So many small molecules are combining together to form a large molecule. So monomers are combining together to form a polymer. Okay, the size is very large. So PVC, it is another example. These are the useful things in our daily life. Then dyes. Maybe your father or teacher, she or he is using some dye. Then your textile industry, paper industry. What is this dye? So anyone, do you know what is this dye? So in the chat box, you can answer, what does this mean? Dye means what? So actually dye means they are coloring materials. In textile industry, these coloring materials, they impart color. Okay, textile industry, we are using dyes. Then paper industry, we are using dyes. So this is also an organic compound. So very big structure, right? So crystal violet dye. So no need to by heart the structure. It is just an example for you. These are the things that we are using in our daily life, dyes. Then medicine, doctors, you are neat aspirants, right? So future doctors. So doctors, you have to tell me what is this aspirin? So what is the use of this aspirin? Why we are using this aspirin? So anyone in the chat box, future doctors, medicos? So chat box, yeah, I'm getting some of the answers, right? Good. So this aspirin, what is the structure of aspirin? So this is the structure of aspirin. There are so many bonds, double bond, OH. So we will study about all this functional group. There is a benzene ring also. Okay, so it is used as a painkiller. So aspirin, medicine, it is also an organic compound. So I hope you understood the importance of organic chemistry in our daily life. Okay, so this is about our daily life. So in NEET and JEE and other competitive exams, what are the questions asked from these portions? So we have to deal with that. Okay, so let's start with the history. So it is very important to learn our history. So the history of chemistry or chemists, okay. So synthesis of organic compounds, how these organic compounds are prepared. So first one, our Jacob Berzelius. So Berzelius uncle, okay, uncle came and he said, he proposed a theory. That theory is known as vital force theory. So vital force theory means what? He said in the living beings, there is a mysterious vital force operating. So this is responsible for the formation of organic compounds. So old definition for the organic compounds, that is the compounds which is obtained or which is present in living organisms or living beings. So that is an old definition for organic compounds. So what about this inorganic compounds? So inorganic compounds means, so these are the compounds obtained from any source except what? Any source except living beings. Okay, so organic compounds is present only in living beings. So we cannot prepare or synthesize this organic compounds outside the living organism. That was the old theory, and a mysterious vital force is operating. This is a very old theory proposed by Berzelius and Gall. Is that true? I don't know. Okay, very old theory. So science has advanced. So with the progress of time, different theories has came. So some drawbacks are proposed. Then after that, in order to avoid those drawbacks, next theory is proposed, right? So Berzelius proposed vital force theory. So organic compounds means compounds which is present in living beings only. We cannot prepare these organic compounds in laboratory. Okay? Is that correct? No, no, no. Then after that, a scientist came. Berzelius is saying that it is not possible. Then we human beings, we like to challenge others. So next scientist came, Wohler. Then Wohler came. What did he do? So Wohler came and he synthesized. Synthesized means prepared it in laboratory. So he prepared an organic compound. So which organic compound? That is urea. So urea is the organic compound prepared by our Wohler. So Berzelius said it is not possible to prepare these organic compounds outside the living things. Then Wohler challenged him and said, no, 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 I will prove you. Okay, I will show you that organic compounds can be prepared in the laboratory also. Then how did he prepare this organic compound urea? He took, okay, like your laboratory, your labs, you know. So in lab, you have to go and take ammonium cyanide. Then this Wohler heated that. Then he got a compound that is known as urea. So urea means NH2, C, double bond O, NH2. This is the structure of urea. So this is the first organic compound synthesized in the laboratory. Who synthesized that? That is our dear Wohler. So Wohler challenged Berzelius. He synthesized an organic compound in the laboratory. So this is the progress of science. Okay. So then after that, other scientists started coming and they said, okay, Wohler has succeeded. We will also synthesize organic compounds in the laboratory. So next scientist, that is Kolb. So Hermann Kolb came and he synthesized an organic compound. Can anyone guess which is the organic compound synthesized by our Kolb? It is given in your NCERT textbook. So Kolb synthesized, okay, what is that? What is that? What is that? Okay, acetic acid. So carboxylic acid. So I can write it as CH3COOH. So acetic acid was prepared or synthesized by Kolb for the first time. So another organic compound synthesized in the laboratory. Okay, then next scientist came. He said, okay, I will also prepare or synthesize some organic compounds in the laboratory. Then who is that? So Marcelin Berthelot. So Berthelot came and he did some experiments and he synthesized an organic compound known as our dear methane. So methane, what is the formula? That is CH4. So methane is synthesized by our Berthelot. So our Berzelius came, he proposed vital force theory. So organic compounds only in living beings. Then next scientist came, then he challenged our Berzelius. So Kolb proposed what? Kolb synthesized an organic compound. Berthelot synthesized an organic compound. Wohler synthesized an organic compound in the laboratory. So we can say Berzelius' vital force theory is not correct. Okay, so we can synthesize this organic compounds in laboratory also. That is a point. These are the points given in our NCERT textbook. Okay, I hope it is clear to you. If it is clear to you, give me some thumbs up or any other reactions. Then only I can understand you got the points. These are the synthesized organic compounds, not only in living beings, outside the living organism also we can prepare these organic compounds, right? So that is about the history of this organic chemistry. There are different scientists, they proposed, they synthesized, okay. So organic compounds could be synthesized from inorganic sources in a laboratory. That is the final conclusion. And we can say Berzelius' vital force theory is not at all correct, right? So shape. So you have studied our chemical bonding chapter. So you have studied valence bond theory. So what is the valency of carbon? Carbon 14th group. So that means 4 valence electrons. So it is tetravalent in nature. So carbon is ready to form 4 bonds. Then only it will complete it octet. So the formation of covalent bond. How the formation of covalent bond is taking place? We have already studied this just for a revision. Okay. So carbon. So atomic number, that is 6, right? So 1s2, 2s2, 2p2. Okay, then excitation of electrons will take place. Then our hydrogen will come, bond is formed. In VBT, I have studied, right? So VBT, actually, VBT is saying that 3 CH bonds are similar. Then 1 CH bond is different. Okay, actually, what is that? Actually, all 4 CH bonds are same. There is no difference at all. So we have studied the limitations of valence bond theory in which chapter? Our chemical bonding chapter. Okay. Then came the concept hybridization. What is this hybridization? Anyone in the chat box, what does this mean? What is this hybridization? So hybridization means it is an intermixing. So in carbon, there are 3 p orbitals, 1s. They will intermix. Okay, they have similar energy. So sp3 orbitals, 4 sp3 orbitals are formed. So you can see in the picture 4 sp3 orbitals. Then after that, our hydrogen is coming and making covalent bond with our carbon. So hybridization of s and p orbital should take place before the covalent bond formation. We have studied hybridization. Okay, so 4 CH bonds are formed. They are almost similar in nature. Then can anyone tell me, so what is the geometry of CH4? CH4, what is the geometry of our CH4? We have studied this in your chemical bonding chapter. So anyone in the chat box, what is the geometry of CH4? Or otherwise, I will tell you the answer. So CH4, you have already studied. That is, so you have to tell me the answer. I don't remember the answer. You have to take your time and tell me the answer in the chat box. CH4 methane, what is the geometry? So sp3 hybridization, right? So that is a shape of carbon compounds. Then we know hybridization, right? So there are different types of hybridization. So methane, that is sp3 hybridization. So how to check the hybridization? There are different methods to find the hybridization. One method you have studied, half of M, that is monovalent atoms, plus valence electrons. Then charge on cation, we are minusing charge on cation, plus charge on anion. We have studied this method to find the hybridization. So M is the number of monovalent atoms. Here, hydrogen, that is monovalent. Then V, that is a valence electrons, carbon, 14th group. There are 4 valence electrons. There is no charge on cation or anion. There is no charge at all. So by this method, you can calculate. Or you can calculate by hybridization is equal to number of sigma bonds plus number of lone pairs. This is another method to calculate hybridization. So let us check carbon. How many sigma bonds are formed? Carbon, hydrogen 1, 2, 3, 4. So hybridization 4 means sp3. So H is equal to 4 means sp3 hybridization, right? Then second we have this carbon, double bond carbon. So this is our alkane. We can say alkyne. So do you know the general formula for alkane? That is CnH2n plus 2. Again, this you have studied in 10th class. Okay, this is our alkenes, right? So we have alkenes. What is the general formula of alkenes? That is CnH2n, right? Okay, so here, so what is hybridization? Carbon. So we have to find the hybridization of this carbon. So check the number of sigma bonds. 1, then 2, then 3. So pi bonds, it is not taking part. So 3 means sp2. The hybridization is sp2. So there are 3 sigma bonds. That means sp2 hybridization. Then our alkynes. Oh, alkyne, what is the general formula? CnH2n minus 2. Right? Suppose, okay, already know that alkane, the general formula. So carbon, so we have carbon, we have to find the hybridization of carbon. So check the number of sigma bonds. Is there any lone pair? No, there is no lone pair at all. So 1 sigma bond, then a second sigma bond, Others are in a multiple bond. First one, we can generally say first one is sigma bond, then other two pi bonds. Okay, so number of sigma plus number of lone pair, that is equal to 2. So H is equal to 2 means what is hybridization? sp hybridization is formed here. Okay, then one more very important point. So you have studied this point in periodic properties chapter. Then what is the percentage of S character? Percentage of S character in SP. So how to calculate the percentage of S character in SP hybridization? That means S and P. There are two, right? Out of that, one is S. So 1 by 2 into 100. Yeah, yeah, I'm getting answers. Tetrahedral structure. Okay, right. That is correct answer. So chem catalyst, that is a correct answer. So here it is 50% S character. What about S character in sp3? That means 1S out of total for 3P plus 1S. 1 by 4 into 100. So I will get, so 25 percentage, right? So 25 percentage. What about sp2? So percentage S character means 1 by 3. So I will get 33.3 percentage. So you have studied percentage of S character that is proportional to electronegativity. So you have to tell me this carbon, sp carbon or sp2 carbon or sp3 carbon, which one is more electronegative in nature. So you can say as a percentage of S character increases, the electronegativity also increases. Electronegativity means what? So it has a tendency to pull the electron, shared pair of electron towards that. So sp carbon will pull the shared pair of electron towards it more powerfully, more strongly. Okay, so one more point. If the S character is more, that means it is close to the nucleus. So close to the nucleus means the nucleus is attracting that, right? So the bond length will decrease. So bond length decreases means what about the bond strength? So bond length and bond strength, they are inversely proportional. So bond length shortens, bond strength increases, or we can say bond order increases here. Okay, so strength of the bond is more. Carbon, triple bond carbon. So percentages character increases. That is electronegativity. Electronegative character increases. This point is very useful in your organic chemistry also. Next year, you will study this alkyl halides and haloarenes and halo. Okay. So in that chapter also, it will be useful. So you have to remember this point. You have to note this point. Okay, done. So this is an example. This is a question for you. So take your pen and paper. You have to do this. So first read the question, then read it properly, then try to answer them. If you're not getting the answer, I will tell you the answer. But you have to try. But you have to try it. So in the chat box, I'm waiting for the answers. Okay. So write the state of hybridization of carbon in the following compounds. And you have to tell me the shape of the molecule also. So first one, CH2, double bond O. So I'm taking carbon. Okay. So I have this carbon, then one hydrogen, second hydrogen. Then there is a double bond O. So what is the trick to find hybridization? The number of sigma bond plus number of lone pairs. So how many sigma bond? Carbon, hydrogen, that is a sigma bond. So this one is a sigma bond, this is a sigma bond. Then carbon and oxygen. So one is a sigma bond. So there are 3 sigma bonds present. So 3 sigma bonds present means what is a hybridization? That is sp2 hybridization. Correct or wrong? sp2 hybridization. So 3. Then CH3F. CH3F. How many sigma bonds? So 1, 2, 3, 4. So 4 sigma bonds. That means what is hybridization? That is sp3 hybridization. Then, so we got the hybridization. You have to tell me the shape. Okay. So you have to tell me the shape here. So third one, I have CH, then triple bond N. So how to find the number of sigma bond plus number of lone pair? There is no lone pair present here. So carbon, 1 sigma bond, second sigma bond. Other 2 are pi bonds. So 2 sigma bonds are formed here. 2 sigma bonds means what is hybridization? So sp is the hybridization. So sp is a hybridization means what is the shape? The shape is linear. sp3 means what is the shape? that is tetrahedral shape. Then sp2 means that is trigonal planar. So trigonal planar, that is the shape of that. So you have to find the hybridization. It is very important. Based on this, you have to use a trick. Then you can solve the question. In NEET, they're asking this kind of hybridization kind of questions from this chapter also. Okay. So note it. So use a pen and paper. Do it. So it's organic chemistry. So organic chemistry is like your mathematics. You have to solve each and every problem. If you practice more, you will be an expert in organic chemistry. Then in told, there won't be any issues. You can easily solve and you will get good grades in your CBSE as well as in competitive examination. Okay, I hope this is clear to you. So based on this, let us do a PYQ, previous year question, NEET 2018. So which of the following molecules represents the order of hybridization? sp2, sp2, sp, sp. From left to right. Okay, so read the question. So sp2 hybridization means carbon is forming single bond, double bond, or triple bond. So anyone in the chat box, if it is forming a double bond, so what is the hybridization? We have already found the hybridization. So you have some more minutes, not minutes, within seconds, you can solve this. So first one. So let us check this one. There are 3 bonds present. So it is sp. No. So first one should be sp2. Then second, yeah, double bond. So this is sp2. That is correct. What about this one? Okay, this is also sp2. What about this one? This is sp3 carbon. So we have eliminated A option. We have eliminated D option. Then how many options are left? So here, this carbon also sp2. Double bond, right? So this one also sp2. Okay. Then what about this one? This one sigma bond, 1 sigma bond. That is 2 hybridization. H is equal to 2 means sp. What about this one? 1, 2. Then there is hydrogen attached. There are 3 sigma bonds. So that means it is sp2. So we can eliminate option B or C. Which option we have to eliminate? So our order is sp2, sp2. Next should be sp, sp. So sp2, B option, that is sp2, sp2. Here it is sp. Here also sp. Why? 1 sigma bond, 1 bond with hydrogen, that is another sigma bond. 2 sigma bond, that is H is equal to 2 means sp hybridization. So I hope it is clear to you. So B is the correct option. This is from NEET 2018. Okay, I hope it is clear to you. Then we have discussed sigma bond. This is like RRR movie. So there is a scene, this Ram Charan and our junior NTR is doing like this. So they are good friends, right? So like that carbon and hydrogen, they are also very good friends. So they are forming like this one. So it's a very strong bond. So sigma bonds are very strong. What about our pi bond? So we are taking 18 molecules in that. This is a structure for that. Then some orbitals are present. Then they are forming lateral overlapping, lateral like this one. So lateral overlapping is formed. So plus and plus overlaps. So what does this plus, minus, etc. show? It shows the wave function. So in which chapter we have studied wave function? That is atomic structure. We have studied this wave function. Okay. So these are perpendicular. There is a plane. Then this atomic orbitals are present. There is sidewise overlapping, not axial overlapping. If it is axial overlapping or head-to-head overlapping, sigma bond. Here it is pi bond is formed. So they are parallel to each other. They are forming the bond. So like this. So if I try to rotate this, then bond will be broken. So it is not able to. In the pi bond, we cannot rotate properly. Or we can say the rotation about this carbon-carbon double bond is restricted. Okay, it is very difficult to rotate that one. So restricted rotation. Then after overlapping, we can see one electron cloud here and one here. So we can say the electron cloud, one is present above the plane, one is present below the plane. Yeah, okay, good. So some of the students are answering in the chat box. Okay, good, very good. So I have mentioned the correct answer. So B option, that is a correct. Good work. So electron, you have to respond to the chat box. So it is organic chemistry. You have to practice. Okay, then only you will be perfect in organic chemistry. So electron charge cloud, So it is located one above and one below the plane of bonding atoms. So you have studied all these things in which chapter? Chemical bonding chapter. Okay. Then this this electron cloud is easily available to the attacking reagents. So this pi bond, it will be easily attackable. So not like the sigma bond that is more strong. Okay, then we have to study about. So real organic chemistry we are going to start. So we have to start with classification of organic compounds. So initially, organic compounds are classified into two. So do you know which are the two types? So organic compounds are classified into acyclic or open chain. It is open, not closed at all. Then next one is cyclic. That means it is a closed chain, or we can say ring compounds. So this is the first classification. So open chain, we already know that. No need to study about this open chain in detail. So we will study about this closed chain or ring compounds in detail. And then again, this chemist, we have again classified this closed chain into two. One is homocyclic, then other is the other one is obviously heterocyclic compounds. Homocyclic and heterocyclic compounds. Okay. Then, okay, sir, again classification. That is homocyclic is again classified into alicyclic and aromatic compounds. Then is it over? No. They have again classified. So they have classified these aromatic compounds into benzenoid compounds and non-benzenoid compounds. So you may be worried. So what is this homocyclic? What is this heterocyclic? What is aromatic compounds? We have already mentioned aromatic compounds, right? So aromatic from aromaticity NEET 2022. So this year NEET, they have asked a question. Okay, so we will discuss about that question also later. In hydrocarbons also, we will study about aromaticity. It is based on Huckel's rule, 4n plus 2 pi electron should be there. We will study about that. So first, let us study about the cyclic, homocyclic, heterocyclic. Okay, so first one is acyclic or open chain compounds. So open chain means consists of a straight or branching compounds. So it is also known as, we have studied this term, aliphatic compounds. Okay, so open chain compounds. First one, your ethane. So C2H6, that is an open. Okay, second one, acetaldehyde. So functional group is aldehyde. So I can write like this: aldehyde is the functional group. We will study about aldehyde later. Then we have isobutane. So we will study about isobutane in detail. Okay, isobutane, neopentane, etc. Then we have acetic acid, that is a carboxylic acid. So what is a functional group? That is C double bond O, then OH. This is a carboxylic acid functional group. So this is a open chain. They can be straight or branched. So it is also known as aliphatic compounds, right? So what is the second one? That is alicycle. Aliphatic, that is over. Second one, alicycle, that is closed chain or ring compounds. So it is again classified, right? So it is classified into homocyclic compounds. And second one is heterocyclic compounds. Homocyclic compounds means, so here we have carbon, here also carbon, here also carbon. It is closed or ring compounds. So only carbon atoms are present. So with carbon, hydrogen, best friend, hydrogen is also there. So it contains homocyclic compound, contain carbon atoms joined in the form of a ring. So it is a closed ring is formed. What about heterocyclic compounds? Hetero means difference. So initially we have carbon and hydrogen. Then we have some heteroatoms like oxygen. So this is known as tetrahydrofuran. So do you know the structure of furan? So we have furan. If I draw two double bonds, then oxygen, that is known as a furan. So it is also a heterocyclic compound. Okay. Then second one, thiophene. So if there is sulfur, that is known as thiophene. So we will study about furan, thiophene, etc. So that is homocyclic. Then heterocyclic. That means sometimes atoms other than carbon are also present. Then we can call it as heterocyclic. That is different atoms are present. So homocyclic compounds, heterocyclic compounds. We will study about all these compounds in detail. This is just an introduction for you. Then we have aromatic compounds. Actually, aromatic compounds, it is based on Huckel's rule. So Huckel's rule, we will study about this Huckel's rule. There are different criteria for a compound to be aromatic. We will study about that. So aromatic compounds are again classified into two, that is benzenoid aromatic compounds. Examples, benzene, we know our benzene, there is a story behind benzene also, Kikuli. Okay, then aniline, benzene ring, then NH2 is attached to that one. So that is known as aniline. Then third one, naphthalene. So all of these contain benzene ring. So they're known as benzenoid aromatic compounds. So what about non-benzenoid aromatic compounds? So see here. So benzene ring, it is not there. So it is known as non-benzenoid compounds. Then example for that, azulene. Again, acetylene in aromaticity, we will study about the structure, whether it is aromatic or anti-aromatic, we will study. Then one more, we have a double bond O and OH. It is known as tropalon. So tropalon also, it is very important. We will study about that in aromaticity. So just we are studying about the classification of this organic compounds. We will study about all these organic compounds in detail. It is very important for your entrance examinations. Okay, I hope it is clear to you. Then heterocyclic aromatic compounds, I have given the example furan. So furans, oxygen, it is making two bonds. Then how many lone pair of electrons are present? Can you tell me? So 1, 2, 3, 4. So two lone pairs are present. Thiophene, same group, 16th group. It also contains two lone pair of electrons. Then we have pyridine. So pyridine contain one lone pair of electron. So can anyone tell me the hybridization of oxygen in furan, then hybridization of sulfur in thiophene, hybridization of nitrogen in pyridine? We have studied this actually. We have studied these points in chemical bonding chapter. So furan, so I will just give you the hint in this lone pair of electron is involved in hybridization. Sorry, resonance. In resonance, this lone pair of electron is involved. So while counting hybridization, we will exclude this lone pair. So we have one bond pair here, one bond pair here, then one lone pair. So lone pair plus bond pair, we will get a 3. So hybridization is sp2. Here also, one lone pair is involved in resonance. So we have to count the sigma bond around the sulfur, that is 2 plus lone pair 1. Say again 3, that is sp2. We will study about resonance also in this chapter. No need to worry about that. This nitrogen, this lone pair is present. Then close to that, a double bond is also there. So this lone pair is not involved in resonance. So we have to count the sigma bond 1, 2. 2 plus 1 lone pair 3. So hybridization is sp2. So all the hybridization is sp2 hybridized. So this is about heterocyclic aromatic compounds. So you have studied already these things in chemical bonding chapter, how to find the hybridization. Okay. Then after that, we have studied about the functional group, then homologous group also. So what is this functional group? So functional group means it is an atom or group of atoms. They are arranged in a specific manner which is responsible for the characteristic chemical properties of organic compounds. There are a lot of functional groups, about 20 to 25 functional group we have to study. So we will learn about this functional group in detail. Okay, some examples for functional group. This OH functional group, that is OH is known as hydroxyl group. So we will study about this phenol also. So OH, that is hydroxyl group. Second one, that is C double bond OH. Then this is attached to benzene. So this group is known as aldehyde group. That is also a functional group. So this functional group decides the chemical properties of this organic compound. Okay. Third one. So we have carboxylic acid, C double bond OH. That is, I can write it as COOH. So it also determines so many chemical properties. So these are different functional group. This is just a beginning. Okay, part 2 is waiting for you. So hydroxyl group is OH. Then aldehyde group, then carboxylic acid group. These are different functional groups present in organic chemistry. So it is an atom. It can be an atom or a group of atoms. They will decide the chemical property of the organic compound. So that is a point here, functional group. Then in your 10th class onwards, you are studying homologous series. So what is this homologous series? It's a group or a series of organic compounds. Okay, then these groups or family contains a functional group. Okay, the definition, leave the definition. Let us go for an example. So I'm taking alcohols. So what is a functional group? Alcohols means OH is present, hydroxyl group is present. So first member, that is our CH3OH. You know, methanol. Second one, the great ethanol. Okay, it's not great. So CH3, CH2OH. Then what's the difference between first member and second member? That is CH2 group. That is a difference. Then we are going to the third member. That means we are increasing two CH2 groups, right? From first to third, two CH2 groups are increased. Then next one, again from third one to fourth one, we are increasing one more CH group. So what is the difference between the first and the second member? The difference is SCH2 group. Okay. Then second and third member, difference is CH2 group. Then third and fourth, difference in CH2 group. What about the functional group? In all these, functional group is OH. So functional group is same and the consecutive members differ by a CH2 group. So that is known as our homologous series. Okay, so CH2, CH2. Then third one, there are three CH2 groups. So these are the group of organic compounds. The functional group that is same, then there is increase in CH2 groups. Okay, one more example for you. That is alkanes. So which is the first member in alkane? That is our CH4. The simplest methane is present. Then after that C2H6. C2H6 we have. So what is the difference between CH4 and C2H6? So difference is one CH2 group. So take the next member. So we are increasing one CH2 group. So difference is CH2. Then next consecutive member. So we are increasing one more CH2 group. So they differ. The consecutive members differs by one CH2 group. So we can call it as a homologous series. So first one is for alcohols. So this is a family. Second one is another family. So these are the different homologous series. This homologous series we have already studied. In which class? 10. Which chapter? Carbon and its compounds. So many students will say, sir, COVID batch, that chapter is deleted. It's not completely deleted. I know that. Okay. So I hope up to this, everything is clear to you. Okay. So we have just started the organic chemistry. It is a very basic things. So by step, we will go to the advanced level. So you have to organic chemistry. It is like your mathematics. You have to practice that. So practice makes man perfect. Okay. So today, I think we can end our class here. I will give you one homework question. Okay. So I will give you one homework question for you. So this is the homework question. So this is your homework question. So this is not a cancel question. Okay. This is from NEET 2015. So you have to count the total number of pi bond electron. So one thing you have to remember, it's not about total number of pi bonds. It's about total number of pi bond electrons. Okay. So in the next class, so before the next class, you have to count the number of pi bond electrons. So this is one question for you, homework question. Then one more homework question for you. So, okay, thank you. Welcome, welcome. So one more homework question. This is again from NEET 2009. So a structure organic compound is given. You have to find the hybridization. That is number of sigma bond plus number of lone pair. So you can easily find, without the trick also, you can find the hybridization of first carbon, second carbon, third, fourth, etc. So here C2, C3, C5, C6. So you have to find the hybridization. Okay, so I got the answer. Okay, good, very good, very good. So is that correct? 4 pi bond electrons. Is it 4 pi bond electrons or so I can check here 1 pi bond, here second pi bond, third pi bond, fourth pi bond. So number of pi bond, it is 4. I agree with you. So what about the pi bond electrons? Is that correct? The number of pi bond electrons, you have to check. It is a homework question for you. So this one more question that is also from NEET 2009. So you have to check the hybridization of carbon atom in this organic compound. Okay. So I hope you will do the homework question and practice, and we will go to the advanced level from next class onwards. Okay. So thank you for attending the classes. Study well, then enjoy your life. Do well in CBSE examination as well as in the entrance examination. Okay. We will see you in the next class. Okay. Bye-bye, students. Thank you for attending the class. We'll see you in the next class. Yeah, check that answer once more.